Welcome everyone to another lecture about complex numbers. In this video, we are going to learn about the conjugate of a complex number, how to obtain it, and how it is applied to simplify problems involving divisions of complex numbers. Let's start with an illustration example. If we want to square the number 7 plus j4, then we get two real terms, 7 times 7 or 49, and j4 times j4 or minus 16. We also get two imaginary terms, 7 times j4 and j4 times 7. So the total outcome is a complex number as expected, 33 plus j56. Even if we replace j with a minus j and find the square of 7 minus j4, we will end up with a complex number. This is expected as well. However, if we multiply 7 plus j4 by 7 minus j4, then the result is a real number because the imaginary portions cancel each other. 7 times minus j4 cancels 7 times plus j4. This is an interesting outcome, and it is not obtained by luck. The real reason is that 7 minus j4 is the conjugate of 7 plus j4, and vice versa. 7 plus j4 is the conjugate of 7 minus j4. And when multiplying a complex number by its conjugate, you always get a real number. Finding the conjugate of a complex number is straightforward. Just replace j with a minus j. So, if z is a complex number a plus jb, its conjugate is simply a minus jb. The real parts are identical, and the imaginary parts have the same magnitude but opposite sign. And notice here the notation of the conjugate operation as a star at the superscript position. To confirm the main property of conjugates, let's multiply a plus jb with its conjugate a minus jb. A times a is a squared, jb times minus jb is a positive b squared, and a times minus jb and a times plus jb cancel each other. So the final outcome is a squared plus b squared, a purely real number with zero imaginary parts. Here are some properties in regards to applying the conjugate operation alongside arithmetic operations such as summation, multiplication, division, and powers. The proofs of these properties are rather easy, but the properties themselves might come really handy in some situations. Here is an illustrative example for your reference. One of the major applications of conjugates is in division operations. When a complex number is divided by a real number, then we simply distribute both terms of the numerator on that single real number. If the denominator is a purely imaginary number, then we get rid of the j by multiplying by another j to get a real denominator. Then we distribute the numerator as usual. But if the denominator has non-zero real and imaginary components, the problem becomes more tricky. In this case, we multiply by the conjugate of the denominator so that it becomes real as we discussed earlier. Of course, whatever you multiply at the denominator should also be multiplied at the numerator. Then all can be simplified and reduced to a single complex number in the form of a plus jb. Now you should be ready to do some of this stuff by yourself. Here are some simple practice problems that you can do by hand, then check by calculator, or if you would, you can check by posting your solutions in the comment section. Thank you for watching. Stay safe and see you in the next video.